Dear prospective students, welcome to this information video about the Master Program in Sustainable Energy Technology at Delft University of Technology. My name is Rene van Swaaij and I am Associate Professor at Delft University of Technology, teaching semiconductor physics for solar cells, and I am Director of Studies of this Master's Program. In this video, I will inform you about this Master Program. I will focus on the motivation of this program. Why do we need a Master's Program in Sustainable Energy Technology? Then I will explain how MSc SET is organized in Delft and will go in somewhat more detail on the content of this program. Subsequently, I will give you some idea of what you can do with this program and I will discuss the admission criteria. So let's first discuss the motivation for MSc SET. There are a number of issues that require the implementation of sustainable energy technologies. First of all, the energy demand. The energy demand is primarily determined by the size of the population, and this is growing fast. At this moment there are more than 7 billion people on Earth, and this is expected to grow to 9 or 10 billion by 2050. All these people need energy for their daily lives and business, and as the population grows, we obviously therefore need more energy. In this slide we see that in all continents the energy consumption is growing and it is expected to continue for the next decades. On top of the increase in energy demand, we see that the consumption of energy is not evenly distributed across the world. In Northern America and Europe we use a lot of energy per capita, and in developing countries this is much less. It is expected that the energy demand per capita in these developing countries will grow as their economies develop, implying an even faster increase in energy demand. In addition to energy demand, people are worried by the consequences of energy consumption, in particular the effects on climate change. This slide shows the increase in carbon dioxide concentration in the atmosphere that is held responsible for the increase in average temperature around the world and its effect on climate events. This increase in concentration is primarily fueled by our energy consumption based on burning of fossil fuels. So we have considered the increase in energy demand and the effect of energy consumption on climate change. If we think about energy supply, we need to consider obviously what is available. This slide shows that at this moment there is still plenty of coal available for energy production. Also there are still reserves of oil and natural gas, although it becomes increasingly difficult to extract these resources. However, the most abundant energy source appears to be our nearest star, the Sun. Solar energy can be used in several ways, directly via photovoltaic energy conversion and solar heat, but also indirectly by stimulating convection on Earth and thereby creating wind energy, or by its effect on tides, etc. The message of this slide is that the Sun every year provides much more energy than is consumed by the entire population on Earth in that year. So in principle, there is plenty of energy available. We only need to tap into this source. This slide shows the pictures Google associates with a search on the Dutch word for energy, energie. We see windmills, PV solar panels, green fields and blue skies. In other words, Google associates energy to what I would call renewable energy. This slide and the previous slides show that society is currently undergoing an energy transition. The transition from a society fueled by burning fossil fuels to a society that will base its energy consumption on sustainable energy technologies. And this is where you as prospective students come in. We need engineers who can facilitate this energy transition and who can design the technologies needed. In order to understand what we mean by sustainable energy technologies, I consider this slide. In the top left corner you can see what I mean by sustainable energy. It consists of two components: renewable energy based on electricity, gas and fuels and heat, and energy efficiency. In the box in the top right corner, you can see some definitions. In the bottom section, you can see how this is realized in the energy field. We consider energy generation, like wind and solar energy, transport via, for instance, the electricity grid, energy storage in batteries or hydrogen, and finally the load, like electric vehicles. These components of generation, transport, storage and load make up the energy system. As I will show later in the MSc SET program, we will focus on this system, and for that we offer in Delft profiles that in this slide are indicated in yellow letters. So how is the MSc SET program organized in Delft? First of all, MSc SET is a multidisciplinary program. The program focuses on several parts of the energy system, as will be shown later. This program is also part of the 4TU Federation, the Organization of Technology Universities in the Netherlands. This means that there are similar MSc SET programs at Eindhoven University of Technology and Twente University, though these programs have a somewhat different emphasis. At Delft University of Technology, MSc SET is an inter-faculty program, and 5 out of 8 faculties of this university participate in the education. The program is coordinated by the Faculty of Electrical Engineering, Mathematics and Computer Science, where I work, but in the program we have courses from the Faculty of Aerospace Engineering, the Faculty of Applied Sciences, the Faculty of Mechanical, Maritime and Materials Engineering, and the Faculty of Technology, Policy and Management. If you study in the MSc SET program, then you will follow courses across the entire university campus. I will now go into more detail of the MSc SET program. And in order to do that, I first would like to tell something about the vision of the program. First of all, the type of engineer that will be trained in this program. In literature, 4 types of engineers are considered, and probably many of you have an idea of these descriptions. For instance, a specialist will be an engineer who knows lots about a very specific topic. In the MSc SET program, however, we focus on training system integrators, so engineers that understand the different components of an energy system and how to put these together. This is the basis for the design of the program as shown in this slide. The program consists of 5 main parts: the common core, the profiles, the system integration project or SIP, elective space, and the graduation project. The engineer that we educate in this program is sometimes compared to a pie shape, a base with 2 legs. However, for the MSc SET program, we consider a pie with 3 legs. The base of this pie relates to the breadth of the program given in the common core, whereas the legs relate to the profiles that give depth in the specific energy topics. Now let's see the different parts of the program, starting with the common core. In the common core, we offer 5 different courses. First of all, the course Renewable Energy by Professor Arno Smets, in which the most important aspects of the components in the energy system are discussed, and you learn to make back-of-the-envelope calculations. In addition, you follow the course Energy System Optimization by Professor Zofia Luxo, focusing on strategies to combine all components in an energy system in an optimal way given the characteristics of these components. For instance, taking into account daily and seasonal variation in solar irradiation. Finally, a course on economics and regulations of sustainable energy systems by Savar Storm that discusses the economic and societal aspects of energy systems is given. In addition to these courses, also mandatory courses are given on MATLAB program and the writing of reports in technical writing. The next important component is the System Integration Project, or SIP. The objective of this project is to design your own energy system for a specific region, like an island, given certain boundary conditions like wind fields and solar irradiation. For that, you will follow some lectures on distributed power conversion, and you will develop your soft skills on presenting in front of an audience. The depth of the program is provided by the profiles. Starting in the academic year 2020-2021, we will offer 7 profiles in the MSc SET program: wind energy, solar energy, biomass energy, power engineering, energy storage, economics and society, and a new addition, electric mobility. Each profile consists of 3 courses with a total study load of 12 EC, and the profiles have been designed to follow the so-called CDIO principle: conceive, design, implement and operate. This means that the first course in the profile focuses on fundamental or basic principles, and that later the courses become more advanced and often focus on system aspects. For instance, the solar energy profile starts with a course on photovoltaic basics, obviously discussing basic principles of photovoltaic solar energy. Then in the course Photovoltaic Technologies, advanced solar cell technologies are given, and finally in photovoltaic systems the design of an entire PV system is discussed. In order to have an energy system approach, each student will follow 3 out of 7 profiles. The profiles have therefore been organized in 8 predefined profile clusters. In the first year of the MSc SET program, you will be asked to choose one of these profile clusters. This program design leads to a schedule as shown in this module chart, in which the first MSc year you will primarily work on courses, and in the second year you focus on electives and the graduation project. These electives can be courses, or you can do an internship at a company, and for the graduation project you will carry out scientific research on an energy topic, either in one of the research groups associated to this program or at an institute or company. So what can you do after you finish the MSc SET program? A survey taken some years ago has shown that most MSc SET alumni find a job before or within a month after finishing the program. We have the impression that this has increased over the last number of years. In any case, most of our alumni have a job within half a year, and if they take longer, they often choose to do so, for instance by traveling the world. Many alumni find a job in a company working in the energy field, but also at universities and research institutes. Some students start their own company, like Eternal Sun Spire, that makes solar simulators. This slide shows companies where MSc SET alumni work, like utility companies as Steden and Alliander, companies in the wind energy field like Siemens and Darwin, but also in the solar energy field like Hyatt Solar and Exasun. So there are plenty of opportunities. If you would like to do this program, you must have a specific background, and therefore we have some admission criteria. Therefore, I would like to start by telling you what we expect from an academic engineer. This slide shows Google's association, and we see pictures of people with hard hats and fluorescent vests. However, it is important to realize that an academic engineer is someone who can find solutions for technological problems for which there are no solutions yet. So what do you need? First of all, we want students to have at least an equivalent study load of 100 EC on exact science topics and engineering topics. In particular, you need to have done at least 20 EC on mathematics. In addition to that, we look for at least 80 EC on physics, chemistry and electrical engineering, or preferably a combination thereof. We understand that BSc programs often focus on one topic, and that is fine, but it is beneficial if you have, in addition to, for instance, physics, also done a little bit or something of electrical engineering. These considerations lead to the following admission criteria. First of all, I need to mention that students with a background at the University of Applied Science in the Netherlands, in Dutch HBO, are unfortunately not admitted to the program. Students of one of the Dutch technology universities have unconditional admission with the following engineering backgrounds: aerospace engineering, applied earth science, applied physics, chemical engineering or molecular science and technology, electrical engineering, maritime engineering, and mechanical engineering. Students with a background in civil engineering are required to do a bridging program of 15 EC in Delft, or alternatively can do the Bachelor of Science minor in Electrical Sustainable Energy Systems at the Faculty of EEMCS in Delft. Students from a Dutch general university like Utrecht and Leiden, and with a BSc background in astronomy, chemistry, molecular science and technology, and physics are usually admitted. If your program is not in this list, you can find instructions for a do-it-yourself transcript review on the internet page of this program. If on the basis of your DIY review you decide to apply, your transcript will then be reviewed by a committee. Students from a non-Dutch engineering BSc program can apply if they have done one of the programs listed here: aerospace engineering, chemical engineering, electrical engineering, mechanical engineering, and applied physics. Please note that you need to be able to show a Bachelor of Science qualification before starting in Delft. Also note that you need to fulfill the general requirements set by the university: CGPA higher than 75% and TOEFL or IELTS language certificate. Before I finish, I would like to point out that you can prepare for this program. The program is very diverse and you will do different topics from the energy field that are in some cases not directly related to your bachelor background. In principle, you can choose any profile cluster once you are admitted to the program. However, for some of the profiles in a cluster you might need to brush up your knowledge and skills. For instance, if you have a Bachelor of Science background in mechanical engineering and you would like to do a profile cluster that contains the power engineering profile, it is recommended that you follow some courses on electrical engineering. For the MSc SET program, we offer 2 online extracurricular homologation courses, namely electrical engineering concepts in the power linkage course and chemical engineering topics in the biomass linkage course. It is your responsibility to make sure that you have this background, and if you do not have this background, these linkage courses are highly recommended. I hope that you have enjoyed this video and that the information that I've given is useful for you to make a decision. If you decide to do the Master of Science program in Sustainable Energy Technology, then I look forward to seeing you at the Master Your Start event on Friday, 28th of August 2020. If you need more information, you can go to the website of this program or contact us on info-set@tudelft.nl. Thank you very much for your attention.